Okay, so 4.1 we're going to be talking about different congruent figures. So congruent polygons have congruent corresponding parts. So they have either matching sides and matching angles. To name it, you must list corresponding vertices, so angles, in the same order. So if we're looking at this picture, angle F is the same as angle F, or angle A is congruent to angle F. If I switch colors, you can see that angle B is congruent to angle G, angle C is congruent to angle H, and angle D is congruent to angle K. Okay, so you have to do it in the corresponding same order type. Okay, so then if I look at sides, AB should be the same as FG, BC is the same as GH, CD is the same as HK, and AD is the same as FK. Okay, so you have to do it in the same order that is given. So I can't have, in this situation, if I'm talking about AD, I have to say it FK. If I say DA, then I have to say KF. Okay, so by all of these being congruent, we can show that these two figures are congruent figures. So they have to have the matching sides and the matching angles for it to be a congruent figure. Okay, so if I have angle, so I'm going to do it down here, ABC, and angle RST, you label it in the same way that you label the second one. So I started from left and I went up and around. I start left and I go up and around again then. So then A should be congruent with R, B should be congruent with S, C should be congruent with T, and then you do the same as the sides. AB should be congruent with RS, BC should be congruent with ST, and so on and so forth. So then, when we're talking about third angle theorem, so if two angles in one triangle are congruent to two angles in another triangle, then the third angle also has to be congruent because they should all add up to be the same degrees. So is angle R congruent to angle V? Well, because these two are vertical angles should be the same, which means they should be equal to each other, which means they are congruent. So that means 95 and 95 are the same, and these two are the same. So if two angles are the same, that means the third angle is the same, okay? And we're going to be saying because that is the third angle theorem. So you might want to write this down somewhere because that is going to be a theorem that we're going to be using later on. So if we're doing proofs, one of the reasonings would be by the third angle theorem, R is congruent to V. Okay, so proving triangles are congruent. So if I have JG congruent to IJ, and GH being congruent to HI, and GI, my two angles, being congruent, we are trying to prove that these two triangles are congruent. Okay, so here are the different steps. I'm writing down the given, and my last step should always be what I'm trying to prove. So here's what I'm trying to prove. Okay, so my next step, reflexive. So if these two segments equal each other, that means my third segment should equal each other. Okay, so that is why HJ is congruent to HJ, and by reflexive. Reflexive is when you have two things that are the same and they're congruent to each other. Okay, so then my next step, if I have G being congruent with I, that is given. So then GJH right here is congruent to IJH. Okay, because all angles are congruent. All right angles are congruent. Sorry. So that means if I have two angles being congruent here, and I already stated these two are congruent, that means by the third angle theorem, this will be congruent. So angle GHJ is congruent to IHJ, so that means these two triangles are congruent. The third angle theorem, since we proved the other two were congruent, that means the third one can be congruent by the third angle theorem. So theorem 4-1. Okay, are the triangles congruent? Okay, so I have to have the three sides congruent and the three angles congruent for it to be congruent. So it looks like I have one side congruent and the other side congruent. So if I have two sides congruent, that means this last side is congruent. So now we need to check to make sure all of our angles are congruent. So these two are congruent. So, and both of these are 90 degrees, which means they're congruent. So if two angles are congruent, that means the third ones are congruent by the third angle theorem. So yes, it is congruent because all three sides are congruent and all three angles are congruent. Okay, find the missing angles. Okay, so I have 3 different sides, and it looks like I have vertical angles, so that means those 2 should be congruent, which makes these ones congruent. Okay, so this is the same value as this up here. So that means I have all 3 of those in the same box. All triangles should add together to be 180 degrees. So if I added 74 plus 5x plus 3x plus 2 and set it equal to 180, I should be able to find this. So 74 plus 2, I got 76 plus 8x equals 180. Subtract 76 from both. So 8x equals 104. Divide by 8. So x is 13. So now I need to find my missing angles. So I'm going to plug them in. So this one I'm going to have 5 times 13 to get 65 degrees. And then this one, 3 times 13 plus 2 should get me 41 degrees. Okay, so all 3 should add together to be 180 degrees for a triangle. Okay, so here's my next one. I have these 2 being the same, these 2 being the same, so we automatically know that these 2 are the same. Okay, I also know that these 2 lengths are the same. So if they're the same, that means we can set them equal to each other because they're congruent. So 2x equals 10, divide by 2, x should equal 5. So both lengths are 10, so my x is 5. Okay, so I have this triangle, so I'm going to make it, or square I guess. So if I have A, B, C, D, so I labeled left and all the way around, so I'm going to do it again. So F, G, H, J. So if the angle B is 3y and angle G is y plus 5, okay, they should be the same because all of my angles are congruent and all my sides are congruent respectively. So I can set them equal to each other if they are congruent. So 3y equals y plus 5. So 2y equals 5. Divide by 2, so y equals 5 over 2, and then I could plug them in to solve. Okay, so now my next one, I'm going to erase what's inside here. So CD is 2x plus 3, and HJ is 3x plus 2. Again, they are sitting in the exact same spot, so those lengths should be congruent, so we can set them equal to each other. So I'm going to erase my figures so I can set them equal to each other. So 2x plus 3 is equal to 3x plus 2. If I subtract 2x, I get 3 equals x plus 2. Subtract 2, so I got x equals 1, and then if I want to find those lengths, I plug x equals 1 in for my x's.